All right, problem number 3, it says a distress flare is fired into the air from a ship at sea. The height h in meters of the flare above sea level is modeled by the quadratic function h of t equals negative 0.2 t squared plus 16t plus 12, where t has to be greater than or equal to 0, where t is in the time in seconds and t equals 0 at the moment the flare was fired. Letter A, they want you to write down the height from which the flare was fired. Okay, the key thing there is asking you to find the height when the flare was fired. That means that the t would have to equal 0. So we're finding h of 0. So h of 0 would equal negative 0.2 times 0 squared plus 16 times 0 plus 12. Should be pretty easy. That simplifies to be 12 meters. Letter B, they then ask you to find the height of the flare 15 seconds after it was fired. Again, pretty simple. They're giving you a t value here of 15 seconds. So t equals 15. So we're finding h of 15, which would equal negative 0.2 times 15 squared plus 16 times 15 plus 12. Okay, that one not so easy. So we type that in, negative 0.2 times 15 squared plus 16 times 15 plus 12. That would get you 207 meters. Moving down to part C, it says the flare fell into the sea k seconds after it was fired. Find the value of k. So we're trying to figure out how long the flare was in the air. So what you could do is set your equation equal to 0 and plug it into y equals on your calculator. So if we type our equation into y1, 0 into y2, and we go to the graph, you might have to mess with the window a little bit, zoom out so you can see the entire graph, but we're looking for that right intersection point with the x-axis. All right, so if I go to second trace number 5 for intersect, move it closer to the right intersection point, and we hit enter 3 times, it's going to give us the time, which is about 80.7. So the coordinates were 80.70, which means that it took about 80.7 seconds for the flare to be in the air. Part D, then they ask us to find the derivative of our function, h of t. So got to take it one part at a time. Negative 0.2 t squared would become negative 0.4 t. The derivative of 16t, since it's just t term, would be the number in front of t, which is 16. And the derivative of 12, since it's just a number, is 0. So this would be our answer to part D.